In this example, a ball is launched at 19.6 meters per second from a 58.8 meter tall cliff. The equation for the object's height s at time t seconds after launch is s of t is equal to negative 4.9 t squared plus 19.6 t plus 58.8, where s is in meters. What is the maximum height achieved by the ball, and when does the ball strike the ground? In problems like that, it's always helpful to draw a little sketch to really realize what situation we're talking about. Okay, so we got a cliff, and there's a person standing on top of that cliff throwing a ball, right? And that ball is probably gonna make a curve like anything that we ever throw, right? And then at some point it's gonna hit the ground. All right, so when will it hit the ground, and what is the maximum height? If we look at that curve, it looks, and it is indeed, a parabola which is opening downwards. Any object that we throw usually curves in the shape of a parabola, and so we are using a quadratic equation here. As you can see, s of t is a quadratic equation, and in order to find the highest point, we need the y-coordinate of our vertex. Well, for the y-coordinate, we first find the x-coordinate, so let's remember our formula. Negative b over 2a, that's the formula to find the x-coordinate of the vertex, right? So let's plug in the numbers. Negative 19.6 over 2 times negative 4.9, which is, well, I'll write it down here first before we do the math, right? But if you look at that, negative 19.6 over negative 9.8, we get positive 2. That's the x-coordinate of our vertex. So let's plug 2 into our equation. S of 2 is equal to negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. And to do the math, the answer is 78.4. 78.4, and that is in meters. All right, so that is the first answer. The maximum height is 78.4 meters. Let's look at our other question. When does the object strike the ground? So in other words, ground means when does it hit the x-axis, right? In a way. Where is the y-coordinate 0? We're talking about zeros. We're talking about x-intercepts here. So let's find those x-intercepts, and looking at our a, b, and c, we can easily see that it's not going to be able to factor this equation. So let's just go ahead and use our newly found knowledge of the quadratic formula, right? So x is equal to the opposite of b, negative 19.6, plus or minus the square root of 19.6 squared minus 4 times negative 4.9 times 58.8, and all that over 2 times negative 4.9. So our discriminant is 1536.64, and in our denominator we got 9.8. Now, as messy as the discriminant looks, it actually simplifies nicely into 39.2. So we got negative 19.6 plus 39.2 divided by negative 9.8, and we got negative 19.6 minus 39.2 divided by negative 9.8. Our two solutions are x is equal to 6 and x is equal to negative 2. Now, let's think about that for a second. We are talking about seconds here, right? And how can the seconds be negative? So we're going back in time. That's not possible. So the negative solution doesn't work out in real life. A positive solution has to be the answer. So we can say the ball strikes the ground after 6 seconds. There you go. Okay, in our next example, Joe's rectangular garden is 6 meters long and 4 meters wide. He wishes to double the area of his garden by increasing its length and width by the same amount. This is going to be an important piece of information. Find the number of meters by which each dimension must be increased. In other words, the amount by which each of the dimensions, length and width, have to be increased. And again, let's go ahead and draw a diagram here for us so we can visualize the problem a little better. We do have a garden, nice little garden there, which is 6 meters long and 4 meters wide. Joe wants to make it larger by increasing the length by an amount we don't know yet, and we always use a variable for that case, right? And the width by that same amount. See, because it's the same amount, we can use the same variable, and that will make it possible for us to even solve this. If it was two different amounts, we would have two different variables, and then we can't just find one solution based on this information. Here is our diagram. So what are we saying? We are saying that we want to double the area. So wait a minute, what are we talking about? We got an area right now of 6 times 4 meters, which is 24 square meters. And instead of 24, we want the double. We want 48. So 48 has to be the product of the length, which is x plus 6, times the width, which is x plus 4. There you go. Now let's go ahead and multiply that out. We get 48 is equal to x squared plus 4x plus 6x plus 24. Or in other words, combining our like terms, x squared plus 10x plus 24. Now we can subtract 48 from both sides to set one side equal to 0. We got x squared plus 10x minus 24. So let's see if we could factor this. We got a target sum of 10, target product of negative 24. Which two factors would add up to positive 10? And the answer is positive 12 and negative 2. So let's go ahead and write our equation in factored form. X plus 12 times x minus 2. And that will give us two solutions again. X can be either negative 12 or x can be positive 2. Looking again, since this is a real world situation, looking at the negative number, does it make sense here? We would actually be decreasing length and width by 12, and then it would become negative. I haven't seen a garden or any type of rectangle actually with a negative length or width, so this makes no sense. Our real answer has to be positive 2. And the nice thing is we can use that and check. So if we added 2 to the length of that object, we would have 8. Adding 2 to the width, we would have 6. 8 times 6 is 48. All right, checks out. Okay, let's move on to our last example. All right, you became a businessman or woman and you run a canoe rental business on a small river in Ohio. You currently charge $12 per canoe and average 36 rentals a day. An industry journal says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. And you're supposed to use this information to attempt to maximize your income. How much should you charge? So basically we're saying we need to find the perfect price which will give us the right number of rentals a day and still give us the highest income. So our income is equal to the price per rental times the number of rentals per day. And that would be our daily income, right? So what is going to be our variable here? What we can use as our variable, the thing that we don't know yet, is how many times should we increase or decrease the price per rental by 50 cents. So X is going to be that increase or the number of increases or decreases in price. So since we're starting with $12 per rental, we can say 12 plus 0.5. That would be our 50 cents. And that is times X, the number of times that we don't know yet. And then we would change the number of rentals a day, which right now is 36, and now we have to put a minus. So every time we add 50 cents to the price, we lose 2 times that, in other words, 2x. Okay, think this through for a minute. It looks a little involved, but it makes perfect sense. The price goes up by 50 cents, the number of rentals go down by 2, and that works as many times as we want to do it. And at some point we're going to hit the point where nobody's going to rent anymore, and that's not what we want. What we want is we want to get the number of rentals which will multiplied by the price we're charging and give us the maximum income. And again, we're going to have a quadratic function. So let's first go ahead and FOIL these two binomials, these two parentheses, and we get 432 minus 24x plus 18x minus x squared. I'm going to shuffle this around a little bit in order to have a trinomial or quadratic function that starts with our quadratic term, combining like terms as we go, and we get negative x squared minus 6x plus 432. And again, what do we need to do here? We need to find the vertex. This is going to be a parabola. Now the parabola unfortunately doesn't open because that means the higher the price goes, the more we're going to sell, and we all know that that's not the reality, right? So the parabola opens downwards, and at some point we're going to have a maximum, and that's our vertex. And right now we're finding at how many increases of 50 cents will we reach that vertex. So negative b over 2a will be the x-coordinate of our vertex, and we get positive 6, the opposite of negative 6, divided by negative 2, which will give us negative 3. X is negative 3. Now what does negative 3 mean again in this context? We're actually going down with the price. We're going down 3 times with our price. So we can go ahead and write that as our answer sentence. Decrease the price by 50 cents 3 times. In other words, by $1.50, and we're going to charge, therefore, only $10.50. All right, so we're actually going down with the price. We're making more money. Sounds interesting, but let's see how much money we can earn that way. Okay, and then we're going to use that value of x, plug it into our function, our income function, and see what we get for an answer. So you can use the space on your left margin for doing that. I'm going to squeeze it in here. So we got negative of negative 3 squared minus 6 times negative 3 plus 432, negative 9 plus 18 plus 432. Negative 9 plus 18 is 9 plus 432, 441. $441 is the income, the maximized income we can make if we charge $10.50 for each canoe rental. And here you have an example of a real life use of these functions, and this is exactly what many businesses do as they plan prices and amounts of goods that they want to sell. Well, so much for that, and I will see you in class.